This is the CCEA Maths GCSE paper. It's the M3 paper from the November series, and it's from Tuesday the 29th November. Let's take a wee look now at question 1. Work out the size of the angles marked A and B in the diagram. So hopefully reasonably straightforward here. This here is on a straight line, nothing to do with the triangle at all. Sometimes easier to cover up, just so you have a straight line there. So A is going to be 180. Take away 130, and of course that's 50. Next one then, this is 50, and because it's an isosceles triangle, then that's 50 as well. So 50 plus 50, so B equals 180. Take away 50 plus 50. 50 plus 50 is 100, so take it away then from 180, and we get an angle then of 80 degrees. Question 2. A local drama group sold the following tickets. The drama group leader started to draw a pie chart representing the number of tickets sold in each category. The first two sectors have been drawn. Complete the pie chart. So they've done here kind of for 15 and 48, and you can see senior citizens then and adults. So first of all, we need to do a total here of how many have been sold. So I'm going to do then 15 plus 48 plus 6 plus 18 plus 3, and that comes to 90, which is obviously a handy enough number for us. And then we need to times things in by 4. Hope you can see why, to make it into our angle of 360 degrees. So if I times this in by 4, that's going to be 24 degrees. Then 18 times 4, again checking our calculator, is 72 degrees, and then this one here is going to be 12 degrees. So for youths, then we want 24 degrees. So they seem to be kind of going on a wee bit of an order here. Senior citizen, adult. So we want 24 degrees in for youths. So again, as accurate as you can. There's my 0, and I'm going round there. There's 10, 20, and 24. So I mark this on here. So that's the one then for youths. Next one is child, and that's 72 degrees. So 50, 60. 72, and we should be roughly left with 12. You don't actually have to measure that last one out, and so my last one then should be 12 degrees. So just a wee check, you can see we're fairly close into 12 degrees, so that's okay. So that one then was infant, and this one here then is child, and that's my pie chart then completed. On to part B then, the table below includes the costs of the tickets. Calculate the total income from the sales tickets. So we have 6 times 15, which I think is 90. 10 times 48, which is 480. 6 times 5, which is 30. 3 18s are 54, and then free for any infants. And we're going to add those up. So hopefully that comes out okay on the video. 90 plus 480 plus 30 plus 34, and that equals then, wait, I've made a mistake somewhere. 6 times 50 is 90. 33 18s in are 54. I've done 34 there instead of 54. Another 20, and we get £654. Sorry about that. At the interval, hot and cold drinks were sold as shown in the table below. The drama, so they sold 4 small hot, 24 medium, 7 large, and so on. The drama group leader said half of the medium drinks sold were cold. Is this statement correct? So half of the medium drinks sold were cold, so that's 12, but they sold 24 medium, and so the answer is no, because there were 36 medium drinks sold, So if you want, then half of 36 is 18, not 12. So something like that would hopefully make sense. Question 3, give your answer correct in the one decimal place. Very much a calculator one then for us, and hopefully we know how to use it. So it's going to be 5.9 squared plus the square root of 80, and we get 43, and then that's going to be 43.8. Hopefully you can see. So 43.7542, I think. And we write that down to 43.8. Just to have a little bit of working out there. Mr. Jenkins is a bus driver. His standard rate of pay is £12 per hour. At the weekend he gets time and a half. If he works a split shift, 2 separate blocks of time on any day, he gets an additional £18 for that day. Mr. Jenkins' timesheet for the first week in January is shown below. Calculate Mr. Jenkins' total pay. Okay, so here he works, let me see if we kind of write the numbers here. So from 8 until 2, so that then is 6 hours. So 6 times our 12, then I think he gets 72 for that day. From here he's 7:30 to 9:30, so that's 2 hours. And then 15 to 22, and that's 7 hours, so that's 9 hours, I think. So that's 9 times 12 then, which is 108, plus a bonus then of 18, because it says he gets an additional £18 then for that day. When this was off, 15 to 22, so that's going to be 7.5 hours, 7.5 times 12 again, just stick that in your calculator if you wish, but 7.5, 12, 7 12s are going to be 84, so another one of those I think then is 90. Friday he was off. Saturday then he gets time and a half, so instead of getting £12 per hour, you can just about see at the top of the screen there, he gets time and a half, an extra half, so he gets £18 an hour. So he's on from 8 then through to 15, so 7 times 18. So he gets 126, and then finally 12:30 to 18:30. So 12 to 18 is 6 hours. So that's 6 times 18. Then for that, so he gets in 108. So let's see if we can get this to work out. So it's 126 plus 108 plus 90 plus 108 plus 18 plus 72. So I think then he gets £522. My working out here isn't great, but those are the different values, and then he gets the 18 bonus. So remember to add the 18 on in terms of that, and then our answer's down at the bottom. We can just about see. I'm putting in my 522 there. Question 5. A farm worker can pick 90 strawberries every 5 minutes. How many strawberries can he pick in an hour? So 5 minutes, how many of those are? There's going to be 12, so it's 90 times 12, and that gives me then 1080. The average picking rate for each worker is 1,000 strawberries per hour. There are 8 workers on the farm. They need to pick 58,000 strawberries for a special order. If they pick at the average rate, how long should it take them? Give your answer in hours and minutes. Well, those guys are going to pick 8,000 per hour because there's going to be 8 of them. So if we do 58,000 divided by 8,000, then that is going to give me 7.25. We've been asked for answer in hours and minutes, so of course then we're going to go 7 1/4, so 7 hours 15 minutes. Question 6, the formula P equals AB over A plus B is using a science experiment to calculate B for the values of A and B. Calculate the value of P when A is 8.4 and B is minus 1.2. So we're just going to substitute those values in. It's going to be 8.4 times minus 1.2 all over 8.4 plus minus 1.2. We want to do the bit on the top and then the bit on the bottom. Good to show a wee bit of working out here as well. So 8.4 times minus 1.2. And on the top line we get minus 10.08. On the bottom line, 8.4 effectively take away 1.2. And that gives me 7.2. So we obviously then just need to divide those two values. So we're going to go 10.08 divided by 7.2. Now I haven't put in the minus here, but I know to change it to that. And so my answer then is going to be minus 1.4. Simplify 5a plus 2b minus 3a minus 8b. It's just join together like terms. The a's are going to give me then a 2a. 2b minus 8b is minus 6b. Multiplying out the brackets, 4 times the 3x is 12x minus 20. And then solving this, I would take 6x from both sides. 2x minus 10 is 2. Add 10 to both sides. 2x is 12, and then divide both sides by 2. X is 6. Goodness. The diagram shows a layout of a rectangular garden. Plants, 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 concrete patio, and distance. There are 4 identical triangular sections of garden covered with plants. We can see those. Calculate the area of one of these triangular sections. You must include units with your answer. Well, it's going to be 3 times 3, so it's the base times the height divided by 2. So the area of a triangle, half times 3 times 3, and that gives me then 4.5 meters squared. There's very few questions in your GCSE you need to include your units. They normally give you them, so you'll be getting a mark then for the units in that one. The garden also has a rectangular path leading to a square concrete patio. The remainder of the garden is covered in grass. Calculate the total area of grass in the garden. So I'm actually just going to draw on this and we'll work out then kind of some areas in from there. So the area of this is 3 times 3, which is going to be 9. The area of this path is going to be 1.5 times 1, so that's just going to be 1.5. And then the area of the whole thing is going to be 9 times 6. So the area of the whole thing is going to be 54. So let's work out some bits and pieces here. The total is 9 times 6, which is 54 meters squared. The patio, I've just shown you there, is 9 plus 1.5. Do you see that there? So 9 plus 1.5. So that's 10.5 meters squared. And then the 4 sets of plant areas are going to be 4 times 4.5, because remember we worked out in part 1 it was 4.5, so 4.5 times 4 gives me then 18. So 54 take away 18, take away 10.5. And that gives me 25.5. And that's in meters squared. On then to question 9. 10 job applicants completed a theory test and a practical exam. The marks are showing the scatter graph. So this was their practical exam up here, and then here was their theory test. What was the highest mark obtained in the practical exam? So in the practical exam, let me see, it's up here, and the highest one up is effectively here, so that's 49. One applicant scored a total of 80 marks. Which applicant was this? So let me see. That person, they get like 23 and 19, so we need somewhere up a bit higher. That person there got 35, and they're still less than that's 35 and 38, so that can't add. It needs to be over 40. So there's G. What's that one? That one's 38 and 42, so that one's going to work. Can you see that? So they get 38 in this one here, it marks here, and then they get 42 in this one, so it's applicant G. Draw a line of best fit on the graph. So a couple of wee rules for this. You kind of want about half of them above and about half of them below the line, and just generally going in the right direction. There is no onus on you at all to go through 0, 0. That sometimes puts people off. So just kind of in the round there. So it's 10 applicants, and I kind of want 5 above and 5 below. Kind of, that C looks like it might get in the way, and I'm not too worried about that. And generally it should go in the right direction. Maybe a see-through ruler is a better option here. So we can kind of see, so possibly something like that. I don't think then is too awful in terms of my line of best fit. So something in and around there. Hopefully that seems okay to me. Question 10. A stem and leaf diagram shows the heights of 19 members of a sports team. 16, that's okay. 4 new players attended trials to become the 20th member of the team. Their heights were 185, 179, 177 and 191. If added to the team, which player would make the modal height greater than 180? Well, there are 19 members, and so the 20th member, then if they were kind of up here, so we were kind of looking to see, so there's currently 19 members, so we want the 10th person, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so we want that person there. So if we were to add someone on this side here, would make the modal height. Sorry, the modal height. I'm really silly. The modal height here. There's 2. I'm working out the median. There's 2 179s. There's 2 185s. If there was 3 179s, then the mode would be lower than that. So it must be the person then who's 185. Goodness me. So the person then is 185, and so that's player A. The range of the height's 28 centimeters. So what's the range currently? The tallest person is 190, and the smallest person is 163. So it's currently 27, and we would need to make it 28. So we need someone who's either bigger than 190 or smaller than 163. So that then is going to be player D. The median height to be 177.5. So we're back to this. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if there's 20 players, 10, then the median height is going to then kind of appear here. So if we get a person who's kind of smaller, then who's kind of smaller than this area here, so where are they going to go? It's going to be player C is the smallest, and so they would kind of go in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there's 10 above, so that makes that person there. So the person C then is 177. A coat has an original price of £87. Online shop offers 33% discount. Online shop B offers a third off. Which shop offers the greatest saving, and how much greater is the saving in pence? You must show your working. So it's a very close one, isn't it? Obviously a third is 33 and a third %. And the other one then is 33%. Which shop offers the greatest saving? So if it's a third, is obviously more off than A. So it's going to be shop B. You could just work out a third of a %. That would be totally fine. And that's going to kind of give you your answer there. Or you could work out then the two values and kind of subtract them from each other. But let's just kind of work it out. So for shop A, it's £87, and I'm going to then take off 33%. So I'm going to do here 87. There's a bit of a quick way of doing it. Times by 0.67. So because you take off 33%, that's the same as having 67%, and so that's then £58.29. For shop B, it was 87, and we're taking off a third. So I'm just going to go then 87 multiplied by 2/3. And that then is £58. And so it's then going to be 29p. Question 12, factorise 8p plus 12t. The letters aren't the same here, so the only thing we can take out then is a 4. 2p plus 3t. R minus r squared, we can take out an r, and it's 1 minus r. And then slightly trickier one here, still only 1 mark, that's a difference of 2 squares. 9 minus t, 9 plus t, and quite often good to check that. If you multiply it out again, you do end up with that. We have that there. Solve the equation y squared plus y minus 6 equals 0. A quadratic, you could use a formula if you wish. I'm going to factorize it. I'm looking for two numbers that multiply to give minus 6, and the same two numbers add to give me a 1. So they have to be plus 3 and minus 2. That means y plus 3 equals 0, or y minus 2 equals 0. That means y is minus 3, or y is 2. On the grid below, draw the graph of y equals 3 minus 2x. So I'm going to rewrite that as minus 2x plus 3. It's exactly the same, but I just like it that way around. That tells me there that the gradient, m, is minus 2, and that the y-intercept is 3. Now if you want, there's nothing to stop you making a wee table of values here, taking numbers for x and y, subbing in and plotting it. That's totally fine, but I'm going to do it this way here. I know it crosses at 3, and a gradient then of minus 2 is across 1 down 2, across 1 down 2, across 1 down 2. Make sure your line goes all the way through the grid that they've given you there. That's our line there. Write down the equation if any line parallel to y equals 3 minus 2x. So anything then with the same gradient, for example, y equals 4 minus 2x, then would be parallel because the gradient is the same for there and there. Two points P, which is 4, 8, and Q, X, Y are joined to form a straight line. The midpoint of the line PQ is the coordinate 1, 7. Find the coordinates of Q. You can use the midpoint formula here if you want. You could do a wee diagram out if you want, or you could just kind of count squares. Just to give you a bit of an idea, I'll kind of do the vaguest of little diagrams here. This is a little bit lazy, but say a 4, 8. So there's a point P there, and that's kind of 4, 8. And then the midpoint is 1, 7. So that's 1 across 7. So that's my midpoint. So my point Q then is going to be kind of over here. Now that's the 0.17. This is the way I'm going to work it out. I can see that they go from here to here. You've got to go across 3 squares. How do I know that? Because the x-coordinate, this is across 4 and this is across 1. So that's across 3 squares. So we've got to go across another 3. That would take me then to -2. Here we've just gone down a square. 8 down to 7. So here then would be down to 6. So -2, 6. Again, there's a midpoint formula if you want to use it. You can use that as well, and that'll help you sort of work it out. If you prefer that method, totally fine. A ball is dropped from a height of 2.5 meters above the ground. Each time it hits the ground, it bounces to 3/5 of its previous height. Kevin says that after it hits the ground for the third time, it will not bounce above half a meter. Is Kevin correct? So here it's at 2.5, and then here it's going to be 3/5 of that. So 2.5 times 3/5. I'm going to do then 0.6, and so that then gives me 1.5. 3/5 then of that, which is then 0.9. And then 3/5 of that, which is 0.54. Kevin says after it hits the ground for the third time, 1, 2, 3, it will now bounce about half a meter. Is Kevin correct? Kevin is just incorrect. It goes just over half a meter, it goes to 54 centimeters there. So the answer is no. We've kind of shown our working out here kind of for each of them. My working out isn't great, but it's going to be 2.5 times 3/5 equals 1.5, and then the new one, 1.5 times 3/5 is 0.9, and then 0.9 times 3/5 then is 0.54. Write down any two numbers whose highest common factor is 8. Highest common factor is 8. So maybe 8 and 16 would work, wouldn't it? The biggest number, highest common factor of those then is going to be 8. Given that 600 is 2 to the power of a times 3 times 5 to the b, find the values of a and b. There's a couple of different ways of doing this. You can kind of divide by 3 and then try and work it out. I'm just going to do my division here and work out its product of prime factors, because this is what this is. I hope you recognize that. So that divides by 2 to 300, 150, 75. So that's dividing it by 2, divided by 2. That now doesn't divide by 2, so it's going to be 3. Which is 25, and then 5, and then 5 until it gets down then to 1. So 600 is equal to 2 cubed times 3 times 5 squared. So A is 3 and B is 2. Question 17. Mary and Anne both go to a shop, each with the same amount of money. Mary buys 7 bars of chocolate at y pence each and receives 19p change. Anne buys 5 bars of chocolate at y pence each and receives 65p change. By forming and solving an equation, work out how much money each girl had going to the shop. So 7y is the price then that she's paid for all the chocolate, plus 19, and that's the same amount as Anne has, and she was 5y plus 65. Because they had the same amount of money, we can put those equal to each other. If I take away 5y from both sides, 2y plus 19 is 65. 2y is 46, and then y is 23. work out how much money each girl had going to the shop. So whatever way you want to do it, you go then kind of 7 times 23 plus 19. Wait, so where do they want the equation? By forming an equation, so my equation then is 7y plus 19 is 5y plus 65. Not quite sure, maybe I'm missing something here about why I have to write that down, and that kind of gets to that mark. And then each girl had what? So 7 times 23, which is 161, plus 19p, and then that means then they have 180 or £1.80. Okay. The cuboid has length 90, width 45, and height 30. And find the density. So density is mass over volume. We need to work out then our volume was 90 times 45 times 30. Put that into your calculator, you get a big number, 121,500, I think. Let me just check that rather than just being lazy. 90 times 45 times 30. That looks right. And so density then equals 24300 divided by 121. You need to put that in as a fraction or just kind of divide it. So I'm going to just divide it. 24300 divided by 121,500. And it ends up then with a density of 0.2. Leah walks 4.7 meters in a straight line. She then turns, so she's walking up this way, assume 90 degrees clockwise, and walks this way. How far is Leah from where she started? So we need, she's now here, she started here, so we need this distance here, and hopefully you can see then it's going to be a Pythagoras. So that's my C, A, and B. C squared equals A squared plus B squared. C squared is 4.7 squared plus 2.5 squared. C squared is 28.34. C then is the square root of that. 5.32. Front door of Martin's house is wooden. The top of the door is a semicircle. Okay, we can see that semicircle there. It has a window with the shape of a rhombus in the diagram. What is the area of the wooden part? Okay, so we're going to work out the area of the rectangle. That's this bit here. The area of the semicircle. And then we're going to take away the rhombus. Hope that makes sense. So, let's see. So the area of that is going to be 2 times 0.8. And that's 1.6. The area of the semicircle. So it's normally pi r squared. I'm going to go a half pi r squared. So that's equal to a half times pi times. Now we need to be careful here. Look, there's the r there. So can we see then that that's going to be 0.4? It's half of that. 0.4 squared. So hopefully we can see this without things messing up too much. I'm going to start with this. 0.4 squared times by pi times by 0.5. That gives me 0.2513. So the area of the whole door then is going to be this plus this, I think. And then the area of the rhombus. So need to be careful here. The rhombus is a bit of an awkward one to work out. So that's 0.2 and that then is 0.3, but then it's going to be half of that. It's a half of the diagonals. Half times 0.2 times 0.3. this is 0.03. So required area then is going to be 1.6 plus 0.2513, take away 0.03. One 1.8213, 1.8213. On then to 21, given that this is identical to this, find the value of A. Don't worry about the 3 wee equal sign, that just means it's exactly the same as, is always the same as, is identical to. So we're going to excuse me, try and tidy this up and see if we can get it to look a bit like this, and then we'll see if we can work from there. So I'm taking the left hand side here, so that's n minus 1 upon n minus 1 plus n minus a. That n minus a isn't really required, the bracket there isn't really required. Here we need to do our FOIL, so n squared, take away n, so that's take away n, and then plus 1 plus n plus n minus a. So that cancels with that, that cancels with that. So I get n squared plus 1 minus a, and they're telling us that that is the same as n squared minus 2. Do you see that then from above? That means this bit here must be the same as this bit here. So 1 minus a equals minus 2. I'm going to take the a over to here and then the 2 over to here. So I'm going to add a to both sides. So 1 equals a minus 2, and then add to both sides, and so I get a value then of a equals 3. Question 22. 1/3 of the pupils in a school are girls. 15% of the girls are in the senior school. There are 306 girls in the junior school. How many pupils are in the school? Okay. 15% of the girls in the senior school, that means 306 equals 85% of the girls. So we're going to find 1%. So we're going to divide by 85. 306 divided by 85, which gives me 3.6 is the girls, and then 100% is 360. So 360 girls, and 1/3 of the pupils are girls. So 360 then times 3 is 1,080. So we have 1,080 pupils in the school. Length of the side of a square is 8.3 centimeters, correct to 1 decimal place. Work out the lower bound for the area of the square. So if it was 8.3, the lowest it could be in each side is 8.25 and 8.25, because it's been done then to 1 decimal place. So 8.25 times 8.25. That equals 68.06. We don't need to round any further then, so 68.0625. Frequency table shows the distance travelled to school by 80 teachers. Complete the cumulative frequency column in the table. So 25 plus 8 is obviously 33. 33 plus 15 is going to be 48. Plus 12 is 60. Plus 10 is 70. Plus 5 is 75. 78. And then 80. So that gives us that. On the graph below, draw a cumulative frequency graph for this information. So we are going to link. Sometimes in these they give you a fourth column where it's kind of a less than, but it's important that we take these points here with these points here. So it's the 0.525 is going to be my first point. It's always less than on your cumulative frequency table. So sorry, my video is not great here. So it's the 0.525. I won't go back and forward here every time, but you can kind of get the idea. It's saying 1033. 1033. Then 1548. 1548. See, then 1260. Sorry, 2060. So 20 is here. Can we just about see 60 here? We can. Again, this camera's not great for this. 25 is 70. 30 is 75. 35 is 78. And then 40 is 80. So we have that. It's not the nicest looking cumulative frequency curve I've ever seen, but that's okay. We'll try our best then to read the information off here. Something like that. So that's that bit there. You can see most of it on there. I'll give you 3 marks for that. Use your graph to estimate the median distance in miles. So the median distance is kind of then, let me see where they, it's weird this because of where this kind of goes out, it makes you feel like you're doing the wrong thing, but there were 80, and so the first 25 of them were kind of all there, so we need to go across then at 40 because you feel like it's wrong. So again, showing where I'm doing across and down, and I'm getting there effectively 12.5. The number of teachers who travel more than 27 miles. So again, I go to 27 here and read off 25, 26, 27. That way, and then kind of hits the graph here, and I go across. That's pretty close, and to me that's hitting, I guess the closest one there is about 72, kind of round a bit there. Now that's the people who travel less than or fewer than 27 miles, so we need to do then 80 take away 72, which is then about 8. Alright. A line passes, final question, a line L passes through the point 02 and 28. Find the equation of any line parallel to the line L. Goodness, okay. So our gradient here, so y, this is equation 1, sorry, coordinate 1 and coordinate 2, so y2, 8, take away 2, all over 2, take away 0, gives me 6 over 2, and that gives me 3, so that means the equation of this line is equal to y equals 3x, and I can tell, because of the point 02, think about where the point 02 is, that's actually the y-intercept, so it's y equals 3x plus 2. We effectively have to give the equation of any line parallel to this one, so we can write y equals 3x plus anything except 2. So y equals 3x plus 1 would be fine then for that. So we've got our gradient there. You can sub in, 0,2 into this or 2,8 into this to get this 2, but you just need to be careful you don't write the 2 down there because it needs to be a line parallel to it. That's us finished.